Hi class, now we're going to continue looking at scientific notation, but we're going to talk about when numbers are written in scientific notation, how we can tell which number is bigger and how many times bigger. Okay, so this problem we say, it says how many times larger is the diameter of the sun, and it has its measurement, compared to the diameter of the earth. Okay, so first when we look at them, we always know which one's bigger by which one has the larger exponent. So we notice this is 10 to the 6th versus 10 to the 4th. So we know this is the larger one, okay? Because the bigger exponent means I've moved my decimal over more places, which essentially makes the number bigger, okay? So if I want to know how many times bigger one number is versus the other, I'm essentially dividing them, okay? So I'm going to take the larger number, which is the sun, so 1.3 times 10 to the 6th, and I want to divide it by the earth, 1.3 times 10 to the 4th. Okay, so again, anytime you want to know how many times bigger one is versus the other, you're dividing them. All right, now when you're dividing numbers in scientific notation, you don't just type this all in your calculator. You do this just by hand. You notice that, okay, you can look at your coefficient part versus your part with the exponent. You can look at them separately. So if I cover this up, I just have 1.3 divided by 1.3. Well, 1.3 divided by 1.3, that just equals 1. All right, so then if I look at this part over here, 10 to the 6th divided by 10 to the 4th, well, if you remember with exponents, if they have the same base, which these do, we can just subtract their exponents. So 10 to the 6th minus 10 to the 4th would make 10 to the 2nd power. So then the answer to this divided by this is just these two pieces. It's just 1 times 10 to the 2nd power, which we can write, in other words, we can say, oh, well, 1 times 10 to the 2nd, 10 to the 2nd just is 10 times 10, which is 100, times 1 would just be 100 times bigger. So the sun is 100 times bigger than the earth in diameter. All right? All right, the next question, we want to know how many times bigger is the distance to Jupiter versus the distance to Venus. Okay, you'll notice this time, this number is written in scientific notation, and this one is not. So I'm going to write this in scientific notation, which would be 4.2 times 10 to the, well, let's see, we've got 3, 6, 7 spots over. All right, so this time I'm going to divide these two numbers. This one has the larger exponent, so I'm going to put it on top, divided by this one. All right, so on this one, I'm going to do the same thing as this. I'm going to divide these coefficients and then subtract my exponents. So 7.5 divided by 4.2, well, that's not going to make a whole number, but let's see what it makes. All right, it makes 1.78, etc. So we're going to say about 1.8, roughly. All right, and then when we subtract our exponents, we get 10 to the 3rd. So then we can put the two of those together. It'd be 1.8 times 10 to the 3rd power. Or we could say, if we move our decimal 3 spots over, 1, 2, 3, that would be about 1,800. All right, 1, 2, 3, yep, 1,800 times bigger. All right, there you go.